So this is the IsoStar client, and this is the scatter plot that we chose to have a look at. This particular one is of that carboxylic acid, and it's looking at interactions with various different groups. What I might do is just make this central group a little bit clearer. So you can interact with this in a similar way to how you can in Mercury, and you can make things have different styles to make the view a little bit easier. So I'll change that to Cat6 so it looks a little bit clearer. So we can see how here various different elements are interacting with this group. And this will be a result of a search done in the CSD for an intermolecular interaction of these types up to van der Waals distance plus 0.5 angstroms. And we can decide which entries we want to see in this particular scatter plot with this interface up here. We could look at just the pure van der Waals overlaps. There's a button for that, which will then reduce the upper limit to 0. You notice how those sliders have changed, and our view has changed down here. So those longer interactions have now been removed from this particular plot. We can just move those sliders ourselves, and this will change the interactions in real time. So you can zoom right down to see the very closest interactions. The bar in the middle lets you move that slice along. So here we're going a slice through that scatter plot. And this can help you to look at the various types of interaction that you're interested in. It's a little bit bigger. Because this particular scatter plot we chose has different types of contact atom, you can see some various different colors here. And the green represents polar atoms, and the red and blue will be oxygen and nitrogen, respectively. And each one of those corresponds to an entry, in this case in the CSD, as that's the type of plot I wanted to look at. And you can go and look at that particular entry by selecting the hyperlink option and then clicking on one of those particular entries. So if I take this one as an example, picked at random, this then goes to the IsoStar server. It picks up the entry that corresponds to that particular point in the scatter plot, and then it pulls the data from the CSV database that relates to that entry and shows that interaction that made it up. And you can see here is the hit for the central group, the acid, and here is a hit to the contact in that particular group. And you can see the rest of the structure around that. So this gives you an idea of what's actually making up each entry in one of these. I could click on another one and it should update. And you'll be able to see that interaction. And here we've got some pairing going on, which is quite a common type of interaction that you might see with carboxylic acids. It'll also show you the particular entry from the CSD database that is making up this particular point, and you can go and view that in Mercury or Conquest if you wanted to look at it a little bit closer. So what kind of questions can one of these scatter plots actually help us answer? So if, for example, I look at polar XH interactions, so this is any kind of NH, OH, or SH type of interaction. And again, we'll look at the CSD. It'll load that up in IsoStar again, and it'll ask you which window you want to look at. This makes it possible to load two plots in different windows and compare them. For this purpose, I shall just load this into the existing window. Again, I shall reduce the display down a little bit so we get to the closer interactions. And we can then start having a look at this and see what is this actually telling us. So we have a carboxylic acid group here, and as you might expect, we've got a hydrogen donor and a little bit of interest in various OH groups up here. But in terms of being an acceptor, this double bonded CO group here is getting a lot more attention than this particular oxygen over here. So very quickly, we've determined something about this central group. We've seen where it's more likely to form hydrogen bonds. And it's definitely this oxygen which has more interest in interactions. Now I can go a little bit further and I can create a contour surface which shows us the greatest density of distributions, and that will help us see more information about what's going on that may be lost in the multitude of hits that we have in the scatter plot. I'll just stick with the defaults here, but what this is doing is essentially creating a contour surface which we want to look at hydrogen, say, and it will show us where that distribution is greatest. Now this has created a contour surface, but you can't see it very easily because of the other plots, so you can hide those. And there you can see we've got a little point that shows you the maximum density of interactions. So that is going to tell you where is the most likely place for a hydrogen interacting with this carboxylic acid group. It's around this location. So this is just one example of one of the types of interaction in IsoStar. And as you can see, we have a wealth of different groups. And this can help you build up a picture of the likely ways these functional groups are likely to interact with each other. What we have done in this recent release is we've expanded that set of groups that are available. The CSD system has grown a little bit, and we are now able to show some groups that have enough data to be statistically relevant that might not have been before. What we've done is add selenium groups, seleno or methyl seleno, to match the sulfur analogues that we already have, and that shows a very similar type of chemistry there. Selenium is now starting to be more of interest in certain drug discovery, so that can help you understand that chemistry a little bit more. We've also added some new ring systems, and you can see for nitrogen containing rings, which we already have a lot, we have added 1, 2, 3 triazole groups, and if I have one of those very quickly, and again look at those polar groups. Let's get Van der Waals. You can see there's more density of groups around this particular nitrogen. So very quickly and easily, it's starting to show you that this nitrogen has a greater degree of propensity for a hydrogen bond acceptor. We have also added a new set of contact groups, and that is the alkali metals. For this particular entry, there are not many results, but we have done a set of searches for all of these alkali metal ions. And this again can start to show you some interesting chemistry. If we look at phenol, for example, and this has a lot more results, the largest being potassium. I shall just load up, and very quickly here, and again, as we go to Van der Waals overlaps, you can see there's a bit of a cluster immediately over the ring. We have a positively charged potassium here, and this ring is relatively negatively charged, so that's perhaps not unsurprising, but it can start to show you how this chemistry is happening with these particular contact groups. And there, picked at random, you can see how that's essentially almost forming a coordination compound with that particular potassium ion. So this is essentially IsoStar. It is a very quick way to visualize intermolecular interactions in both CSD and PDB data. I've given you a very quick lightning tour, but we do have a set of tutorials and help documentation that comes with it if you want to look at it in a bit more detail. But the key strengths of it are it helps you look at these interactions very quickly and easily pick up a very good feel for how these interactions actually happen. It's a very important piece of data that we have at the CSD, and it actually underpins some of our other applications, such as full interaction maps in Mercury and IsoStar that you can also find in Hermes for analyzing proteins. So it's very important chemistry, and it is continually being expanded. And that is it from me.